My name is Mike Goelzer. I'm from the Filecoin project. You can reach me at mgoelzer on Filecoin Slack. And I just want to sort of introduce things by talking about first, just a second, what is the retrieval market? So if you go back to the original Filecoin white paper, the first Filecoin paper came out in, I think, 2013. It's been updated several times, but what it describes is actually two markets. So the main one is the storage market. That's the one that is launched this week. That's the impetus for the whole Liftoff week. That's what the Liftoff is. And the storage market is where you buy storage from different storage miners who are competing with each other to provide the best reliability at the lowest cost. But the paper also talks about a second market, and that's the retrieval market. And the idea with the retrieval market is that in some cases, you'll have content that you want that's not private to you. You want people to be able to retrieve it, a large number of people. And so in that case, what you actually want is for the providers of retrieval to be in a competitive market with each other where they're competing to provide you with certain content at the lowest cost at the highest reliability. The same idea as the storage market. And so what we're going to do tonight is hear from 4 different teams who have taken different approaches to this problem, and they all have very interesting perspectives on it. So I think it's going to be a good event. I want to ask the presenters, please keep yourself to 10 minutes, and for the audience, please feel free to use the Q&A at any time. You can ask questions, and presenters can address them either in their presentation or in writing after they finish. So with no further ado, I want to move to Peter, David, and Robert from Consensys to hear about their retrieval markets architecture.
So as Mike said, I'm going to talk about, so I'm Peter Robinson, and tonight I'm going to talk about the Filecoin secondary retrieval market architecture. So David Highland Wood and Robert Drost and I have collaborated to create this. So when you're thinking about markets, there's the primary retrieval market and the secondary retrieval market. So primary retrieval is really about going directly to a storage miner to get your content. Whereas a secondary retrieval, it's all about discovery and having the information in highly available off-chain sources. And so it's all about being able to discover where the content is and being able to get it. And by market, it's all about having choice and being able to have a market between buyers and sellers to find the best deal. So you can think of a primary retrieval as you've got a Lotus node which talks directly to a storage miner to get the content. So when we were thinking about this, about what the objectives for this system should be, discovery is obviously a big one. We need to discover where the content is. We need to promote caching in the network so that you might have content cached near you. Low latency is incredibly important. So people want to be able to get their content and have it available immediately. We need to support massive scaling, so 2 to the 60 objects in the system. And we need to have an appropriate incentivization system so that we have a healthy ecosystem. So this is the overall grand plan. And so rather than trying to attack it in one big diagram, let's go through it piece by piece. The retrieval client is a software library which integrates with applications. So you might have an app that might run on a phone, on desktop, on browser, or on all of those platforms, and you want to be able to integrate it, integrate a library so you can access your content on Filecoin. And rather than asking for every single CID in the whole system and discovering that, we've broken down the problem into finding a piece CID, and then based on that, then you find a CID. And so this breaking down of the problem allows for 2 to the 60 objects to be supported. Retrieval providers publish offers. So they are essentially saying, we will supply this content at a certain price, and here's an expiry date for this offer. And so you can think of the idea about these offers, as I said, is associating with all of the content inside of a PCID, the cost of the content, the expiry date of the offer, and some quality of service metric around that content. And the reason for having CID offers is really latency. So if you go with the bid, ask, deal mechanism, you've got 2 overall round trips there. Whereas if you've got and you might have to talk to a variety of miners. Whereas if you can have these pre-signed offers, then you talk to a single node and it can give you a list of offers for that content. So you have much better latency. And so these retrieval gateways, they hold the offers that the retrieval providers have published. So the retrieval providers are connected with storage miners and they publish these offers. And then the gateways hold a set of offers and the clients talk to the gateway and then they get the offers. So which provider will provide the content at what price. And to have a market as well, just in case, say, one of these retrieval gateways turns out to be malicious, or maybe it just doesn't have all the offers, you might talk to a variety of gateways. And not all gateways might have all of the information because you've got essentially a publication subscription model of the retrieval providers publishing the data, and some of the retrieval gateways might choose to store it, but they might not choose to store other pieces. So because of that, we've created a DHT for discovering content. And so if a gateway doesn't have a PCID and offers for a PCID, it can use the gateway DHT to locate that information. And this gateway DHT is not your typical DHT. So your gateway nodes register on chain in a gateway registration smart contract. And when they're registered, they're staking some money, some Filecoin, so they can be slashed if they provably do bad behavior. And the number of gateways is likely to scale with the network, but you'd assume tens of thousands of gateways is probably going to be your upper limit. So you're going to be able to have a table of all the possible gateways in memory in one of those nodes. So because of the registration process and the staking money, it means that the nodes are going to be stable. They're going to be long-lived and the addresses are known. And what this means is that we should be able to do a single hop DHT. So that means you should be able to talk to any one gateway and it will know which other gateway or set of gateways will give you information about that PCID. And there's redundancy across nodes just in case nodes fail or nodes are malicious. And so the DHT is a ring DHT, but a gateway effectively owns an area within the ring. And so it has to cover all the CIDs that are in that ring. So you can see all those in the middle, you've got blue PCIDs, and on the outside, you've got the gateway IDs, and they map to the same number space. And so in here, the example I'm showing is where the DHT span would be 4, but in a typical system, it would probably be more than that, maybe 16 or so, maybe, and we're finalizing that number. So in addition to what I've shown, there's also the possibility of having these retrieval providers not associated with a storage miner. What that gives you is in-network caching. So say I live in a city that is far away from where all the storage miners are who have the content. If some content is hot, and the retrieval gateways will be able to detect that the content is hot, then it could choose to work with its own retrieval caching provider to store that content locally and get retrieval fees based on returning that content. Also, content needs to be paid for. And so typically it could you could do it through a gateway if they have payment channels set up. But additionally, you could imagine nodes emerging called payment brokers that would have payment channels with all of the providers. As well, not everyone might have Filecoin. And so a subscription service where maybe you pay $100 a month or $20 a month, some amount per month to a subscription service, and then it retrieves as much content as you need on your behalf. So that's all I've got time for today. And please fire me any questions if you have any.
I am going to present on the browser-based retrieval network that we built, the Filecoin project built over the summer. And so I'm just going to set my timer. I'm also going to do a demo of the software. It's very close to being usable at this point. It's taken us a while to get there. So basically, let me just explain what this whole thing is. The idea is that browser clients, we have a peer-to-peer network of browser extensions. So the software is a browser extension. You install it in your browser, and then your browser becomes part of this peer-to-peer network that anyone can join. And there are two things you can do. You can download CID from another browser client who is storing that particular piece of content, or you can make a request to the Filecoin storage network and retrieve from a storage miner. And the way that you talk to the storage network is through something called a cloud Lotus, which is a concept that we invented, but it's a public Lotus instance. It doesn't have any wallets on it or anything. You only use it to you sign a message and then you submit it to the cloud Lotus, and that message will go into the message pool and get mined and get incorporated onto the chain. So the cloud Lotus is really just a vehicle for you to publish messages to the chain. So the advantages of this model are there's no Lotus node required. You don't need to run your own Lotus. You also don't need to trust the cloud Lotus, by the way. Your signing keys stay in your browser. They're never shared with the public Lotus. It's just, you just send it pre-signed messages and it publishes them. So because there's no Lotus node required, you don't have to wait to sync to the chain, which can take like a week or something. And you can just do retrieval mine by leaving your browser running. So that was kind of the concept behind this. Okay, well here, I'm gonna go to the demo now. Live demos almost always fail for some reason. So here's a bit.ly link to a pre-recorded version of the demo I'm about to show you. You can check that out if I fail now, but let me try to give this a try. So one sec, I need to hide a bunch of controls. Okay, so this is what the browser extension looks like. Obviously, we haven't done any web design or any kind of put any thought into graphic design or anything. Most of the complexity of this is kind of behind the scenes. But the basic idea is you're on a peer-to-peer network. Right now, I'm running this browser extension in both Chrome and Firefox. So each node sees that there's one other node on the network, and that other node is just the other browser. And so you can do two things. You can either request data, you can query for a CID and request it from the other nodes on the peer-to-peer network, or you can be a provider of data. So you see that this Firefox is storing a CID already. It's about 4 kilobytes. What we're going to do is request it from Chrome, and then I'm going to explain a little bit about Filecoin payment channels and what's happening behind the scenes. So let's take this, copy it over to the clipboard, go to this Chrome one. This guy doesn't have any CIDs stored, so you don't see anything there, but we can still query for a CID. That's going to send a message out to all of the other nodes on the peer-to-peer network, and that message is requesting the CID. Now, in this case, there's only one other node, and it happens to have the CID since I copy and pasted it from Firefox. So this is the Firefox node responding. And what he's saying is, yes, I have the CID. Here's my price for it, 3.7 million autofill, which is an autofill is 10 to the negative 18th Filecoin. So this is actually a very small price. Just to show you quickly, you have configuration options. So you can set a price. Star means is a wild card. It means all CIDs are going to be priced at 10 1,000 autofill per byte. You can also do it on a per CID basis. And so anyway, this price makes sense, right? The file is about 3.7 thousand bytes roughly. So times 1,000, the price would be 3.7 million autofill. So now we're going to hit the buy button and a transfer is going to start. And you can see this guy is downloading, and we see on the Firefox, he's uploading. Now, there's a lot happening behind the scenes, and you can see it in the logs. Actually, both have logs. And but rather than walk you through an execution trace of a program, which would be very boring in a demo like this, I've actually made a slide to explain what is happening right now. So here's the basic idea. The Chrome extension is buying a CID, and the Firefox is selling it. So the Chrome extension needs to create a payment channel, and then it needs to exchange signed vouchers with the Firefox in exchange for chunks of data. So the Firefox sends a chunk of data, and then the Chrome extension sends back a signed payment voucher. And then you can go around in this loop, 2, 3, 4 loop for as many cycles as it takes. I think the default chunk size right now is 1 megabyte, and it increases each time. It's a model of escalating trust. So anyway, you go around that loop for a while, and for a 4 kilobyte file, you're only going to go around that loop once, but then eventually all the data is transferred. At that point, the Chrome has sent all of the payment vouchers. He's out of the picture now, but the Firefox, who's the blue text, has a bunch of things that he needs to do in order to get paid. So first he calls a method on the payment channel actor called settle, and that means that the transfer is over, and it opens up a 12-hour window during which the Firefox extension can submit signed vouchers to the channel, and that's an on-chain operation, gets published on chain. And during that 12-hour period, the Firefox browser would submit the highest value voucher it has received. Each time you go around that loop, the voucher values get higher and higher. So there's always one highest value voucher that the provider of data will have. And so he submits that, it's published on chain. Then 12 hours or more later, the Firefox can call collect on the payment channel actor, and that is what actually distributes the funds, tears down the payment channel. And so if the transfer is successful, 100% of the funds would go to the Firefox. If the transfer broke down halfway, then 50% of the funds would go to the Firefox, 50% would be refunded back to the Chrome, the requester of data. So that's how the model works. I'll just show you really quickly in these logs. You can actually see a lot of this stuff going on. Like here, this is Chrome. You can see this is the signed payment voucher that he sent. That's what a payment voucher looks like in base 64. It's actually a CBOR encoded as a structure. And then you can see some of the operations that are going on in the Firefox as well. I think up here he checks the validity of the voucher, which is a signature check to make sure the voucher is really coming from the Chrome, and that it's that it's real, and also a verification that the amount is correct. And so I just want to wrap up by saying this is an open source project. Anyone can participate. We have probably about 10 contributors right now, and we are very close to having everything working. I think the one thing we don't fully have working yet is the retrieval from storage miners. But I think a lot of that stuff will come together this week, and I'm hoping to get more people excited. So this is the repo, and there are instructions for how to install you clone the repo, and then how to build it, how to install it in your browser. And there's a little more information down here about what's complete and what's incomplete. So that's all I have right now. Thank you very much.
Yeah, thanks, Mike. That was a really awesome demo. My demo is actually quite similar in implementation. So here I am running, for the purpose of the demo, of course, two versions of what we have is a decentralized Filefinder. So I'll just go ahead. On my right, we have the provider. On the left, we have the client, which are exactly the same app. We're just running two different roles. So I'll go ahead and load some data here in my provider. So both are running IPFS nodes. And so when I'm loading this, I get automatically a content CID. And so for retrieval here, we are only supporting by content ID, but obviously we will be supporting different types of naming systems in the future. So as I make a query for this content, I can immediately see this local peer, which is found through local discovery right now. And so I can just kind of load and get a quick preview of the content directly through IPFS, then get the ask. And so the same kind of parameters as Mike outlined. And so we're ready to just kind of hit retrieve. So right away, we are loading the content and creating the initial payment channel. So while that's processing, I'll just kind of run you through what we've been up to. So I'm Toma. I'm the co-founder of Mile. And what you're seeing is our first prototype, which we call Beam. And so our vision is kind of twofold. First, we want to kind of increase the speed of retrieval on Filecoin. And then we want to enable anyone to just monetize their extra storage and create new sources of income. And obviously, we want to get those solutions to market as soon as possible. And so, we've been focusing on two challenges. Is as a provider, how do you find content to serve, which, as we've seen in the previous presentation, is definitely a challenge. And then as a provider, how do I serve the best deals, which means how do I most utilize the available storage I have to essentially maximize the income. And so our strategy is really for our network of providers to collaborate instead of competing. So how do they collaborate? They collaborate by sharing information, and they share information about deals, about content. So as soon as you've shared a content ID to one peer in the network, this information about content is kind of spread. And essentially, we have this idea of this concept of a deal faucet. So as soon as you join the network, you automatically get propagated through GossipSub a feed of content. And so any Mile peer can become kind of a faucet. So what that means is that they run additional caching of information through events, and then they run some type of local optimization that we built a prototype of it during HackFS actually over the summer. And so now we're kind of experimenting with different models to optimize this process. And so right now, this is very simple. It's kind of manual a little bit, but we try to make it really a very simple app that anybody can download and tweak their parameters. And then gradually, we're going to automate things. So essentially, you just kind of run the app and it automatically optimizes the best deals for you. So behind the hood, it's really using your normal IPFS nodes. It's using each of those two apps are running libp2p nodes, and so we kind of reuse the same kind of data transfer protocol as Lotus is using. For example, when you retrieve from Lotus, you have the same kind of graph sync data transfer where you can kind of track the number of bytes and get events. And so what really is interesting for us is to kind of record as much about those events and understand how the retrieval deal happens and what was the speed, what was the feature, and how can we optimize this? How can we see which client worked better, etc. It looks like we're sending a new voucher, so we're really close. There you go, transfer. We're getting the first bytes. There we go. Okay. So we're good. And here is the content. It automatically it's showing here now. And so essentially now, there's normally a notification that pops up, but it sounds like it showed on my screen and not the one I'm sharing. But now both any parties can settle this transaction. And there's actually a payment channel open. And so the interesting part is what kind of relationship those two parties can build in the future. And so we really anticipate that clients and providers can build longer term relationship. And what happens is by investing more in the relationship, you can essentially put more funds in a payment channel, for example, and reuse the same payment channel to avoid having to wait, for example, for this message. So we're really kind of exploring different relationship between peers and ways to kind of build trust in the long term to kind of, go faster and not have to go through all those different processes to verify that content is stored, et cetera. So we actually have another kind of prototype exploring different types of payments as well for ETH Online that we're about to showcase. So definitely tons of features, and we'll be releasing this for people to play very soon. So that's our presentation for today.
So yeah, I'm David, and I'm joined today by my colleague Elizabeth, and we're here to show you guys some stuff that we've been doing utilizing gossiping to enable some of the functionality of secondary retrieval markets. So as we've kind of talked about already, looking at the existing protocol, this is kind of the picture that we see. We have clients interacting directly with storage miners to both store and retrieve files. But when we start to look at the secondary market, the picture starts to look a bit more like this, where we're depending on these providers that sit just outside the immediate network. And then clients are interacting with them, and they are in turn interacting with the network as necessary. Some of the benefits of doing things like this is that we can reduce some of the reliance on storage miners and allow them to optimize their setups specifically for providing storage services. It also lowers the storage requirements for providers who are participating in this system. They can instead focus on expanding their resources on getting faster connections or better geographical locations and stuff like that. It also helps improve the availability of all the data on the Filecoin network. We have more nodes that are caching that data and are providing access points. One key benefit of doing things this way is that we're really avoiding some of the complexity in the core protocol. It provides all the kind of fundamentals that we need, and then we can really build a more powerful and dynamic system as an extension of that. And one of the really cool points here is that this data does not necessarily need to be stored on Filecoin. We can certainly construct a mechanism in which any data can be referred by CID, and assuming that it's profitable to provide, you can kind of expect its lifespan of availability. Looking at some of the key requirements for building this sort of secondary retrieval system, some of these things we already have. So content addressing is definitely a big one. It really allows us to guarantee that the data that we're retrieving is the data that we're asking for. It also allows us to address it in a global context so that any retrieval provider who's coming onto the network will immediately be able to identify any kind of any CID effectively. There's also the data exchange protocol, which is primarily for doing the actual data transfer, but it's especially critical here in that it needs to protect both parties in the transaction that occurs through the payment channels that we've just been looking at. Some of the things that are still kind of in progress here are the discovery mechanism. So really figuring out how to find the best provider for a user. And that definitely, the definition of best varies a lot depending on the context that we're in. And then one big requirement here is kind of considering the lost opportunity cost of storage, so that if somebody is expending resources to store something exclusively for retrieval, that they couldn't perhaps be making more of a profit by just storing that instead. Some of the goals of the implementation that we've built here are to provide a novel discovery mechanism, specifically using Gossip Sub, to just allow the clients to find providers of their data. We also wanted to start to inform providers of what data is being requested. This is really to allow them to develop mechanisms for caching and try to analyze the network and understand what is really profitable. And one key goal here is to allow these participants to be exclusively retrieval providers. So remove any dependency on the kind of storage minor components. Looking at the basic flow here, we have a client who's looking to retrieve some data and several providers. That client will simply submit a query, and the providers will gossip that to their peers. Any provider that is willing to offer the retrieval can do so by directly engaging with the client. And then the client can select which of those to follow through with and perform the data exchange with them. To just look at this from a slightly different perspective, the client is simply a component that is responsible for submitting requests, and then it's accepting responses directly from providers and acting upon those. The provider piece is specifically listening for those requests. It contains some data store of data that it's making available, and it's responding with this response structure to allow the clients to decide if they want to engage. Definitely one of the big challenges in all this stuff that we've been talking about today is really optimizing for profitability or potentially availability, depending on what incentivization model we're really looking at. One of the big challenges for providers is determining if it's worth spending the cost themselves to actually retrieve something from the Filecoin network and make that available for retrieval. They could certainly use alternative means for obtaining the data that they're providing. A lot of this stuff is very volatile and subject to change. Certainly as the incentivization model of Filecoin grows and adjusts, we'll see some changes here, as well as the popularity of any given piece of data definitely plays an effect on how available it needs to be made. And then it's also important to consider that the locality of a provider could definitely have a big impact on this. Any one provider is going to have a very different perspective on the network. And so it's important to kind of take that into consideration when you're looking for optimizations here. Just some very simple things that we've done to just kind of make this a little more usable and explorative. It has a built-in LFU cache just to simply keep track of the n most frequent requests, so that somebody can kind of take a snapshot from here and see what is popular around that node. And then there's also a more extensible measure to allow some external service to actually hook into the request. And then it can apply its own logic as to determining profitability, and in turn decide perhaps whether or not to retrieve that from the Filecoin network. So our work can be found here on GitHub under Chainsafe/Phil Secondary Retrieval Market. In its present state, it is effectively the query and response mechanism, kind of our next aim here is to integrate some of the existing Go tooling for markets so that you can actually do the retrieval within the same process. And now that we've actually completed another interface for that, we can look at moving ahead with that. So yeah, I'm going to turn it over to Elizabeth to do a small demo, but certainly check out the repo. Feel free to reach out to us if you have any questions or are interested in this stuff.
Hey everyone, so I'm going to do a quick demo of just using the secondary markets. So what I have here is the Lotus node running with, so this is a fork that we have that has the secondary markets inside of it. So, and I also have the storage miner running here. So I am just going to quickly get the, so I'm just going to use our secondary client to query the Lotus node for some data. So I'm going to first import some file into Lotus so that it can be retrieved. So I think I have just some random text file here. Okay, cool. So then I'm also going to print out the, what's it called? The addresses for the node. So yeah, so I'm just gonna use the secondary client. So I'm just building it. Okay, and then build retrieval client. And I'm gonna connect it to the Lotus node and then query for this CID that I just imported. And then we should be getting a response from the node. Okay, cool. So we have a response from the secondary provider inside the node. So yay, that's good. Okay, so then I'm also going to very quickly show just the provider on its own as well. So without Lotus. Okay, so I'm gonna launch, I think I'll just do 2 for now. I'm gonna launch one of the providers with some data, or I'll let it know that it has access to some data. It doesn't really need to necessarily know about the data yet at this point, since it's just letting the client know that it has it. So sample data.json. Okay, so I'm starting this with some data. And then
Hey, Elizabeth, could you wrap this up in about 1 minute? Is it possible?
yeah.
Okay.
Sorry, this is the last thing. So then I'm just gonna start this one with connecting to this provider. Oh dear. Okay. Okay, so, okay, cool. So that one has no data and it is also connected. So now I'm just going to connect this and then query for the data the first one has. And then we should only get one response from this guy. So yeah, cool. So we got it. The parameters that it would like for the retrieval. Yeah, so that is the demo for now. So cool. Thank you.
While we're waiting to see if there are any audience questions, I'll just ask a few questions. The first one I had was for the Consensys team. I think one of the things you've put a lot of thought into is different parts of your system where entrepreneurs could come in and it would be profitable for them to, they'd have some way to make profit. So can you just explain a little bit about what the incentives are in that system, Peter?
Sure. So you've got, for a retrieval gateway, you've got incentivization for you to do essentially the lookup between a PCID and CID offer. So who can give me that content? You've also got incentivization for participating in the DHT, though if you're going to run a gateway, you have to do that, but you get recompensed for that. So you get recompensed for seeing if you've got something, and if you don't have it, you'll still get something, and you get recompensed for giving the content. As well, there are providers. And so providers either get paid to return data, but if you've got one of those caching providers, it would be a way of you making money by running a gateway, seeing what's hot, and then hosting that locally, and then being paid for retrievals.
Okay, great, thank you. I also had actually another here. I have a question for Thomas from Mile. Can you tell us a little bit about, I know your project started at HackFS, so is everything open source, or is part of it open source, like open core, or what's your model like there?
Yeah, so we haven't invented any new protocols, so it's basically using all the available Lotus and Filecoin IPFS storage Legos. So it's been really about stripping everything down to exactly using what we needed. So there's actually open repos where most of the backend that's happening is all available, but the UI is closed source. So we have been developing our own native app in a private repo.
Okay, interesting. Yeah, I think that, do you also rely on a public Lotus node? Or are you running a client-only Lotus on your Mac, or how does that work?
Yeah, so I used to run on my Mac a Lotus node, and then I just ran out of space. And so it really made me realize that I needed that to be stored somewhere else. So yeah, it's kind of the same as your node, very like, I mean, right now it's a full node, but eventually, I mean, it's just like a light client type model where we're just getting the chain head and replicating some of the state locally, but and wallets and everything is local, but you're connected to kind of a message pool and everything remotely.
That might be an interesting avenue for collaboration, I think, because I'm also interested in hosting a public cloud Lotus. I want to harden it a little bit, close off some of the APIs. Yeah, but yeah, so that could be interesting. We can talk about that offline.
Absolutely.
Yeah. I just wanted to ask Chainsafe. So, what can you talk a little bit more, David, maybe about the next steps? I know you want to decouple the storage miner from the retrieval markets code, so that you don't have to also be running a full storage miner, and just talk a little bit about the direction you'd like to go with this.
Yeah, certainly. I mean, as it exists right now, it's definitely it's kind of POC stages. There is some great work by Hannah and a number of other people on the Filecoin team in the Retrieval Markets repo, which really provides the kind of fundamental building blocks to perform retrieval. And so we would definitely like to integrate that component with our provider to allow it to exist in isolation. And then we can really start to deploy it in a variety of circumstances and play around a bit more with the discovery mechanism. Also, from the client perspective, being able to run the Retrieval Markets piece, much like how you were just talking about, without actually depending on a private Lotus node. We have just built an interface to allow that to be a lot simpler, so you can run against any node. We definitely hope to, yeah, very soon have it up and running against some of the other Filecoin implementations.
Okay, great. Yeah. All right. Well, thank you.